Hello students, I am Arunkumar, Assistant Professor from Department of Biostatistics, School of Political Science, Vinaya Missions Research Foundation, Salem. So today we discuss about hypothesis testing. Hypothesis testing is an important topic in field of statistics. Okay. So in this session we discuss about what is hypothesis and what are the types and how to test the hypothesis and how to make decision on hypothesis. Okay. So before enter the session, so I remain some basic terms of statistics. First of all, what is statistics? So statistics plays a crucial role in data analysis and making conclusion based on data. Okay. So statistics is classified on two types. So one is descriptive statistics and another one is inferential statistics, right? Descriptive statistics means just describe or summarize the data set. Okay. What is data set? Data set means collections of informations. Okay. So information may be anything. So for example, our body weight, height, BMI. So these are all our informations. Okay. So collection of information means large number of information. So we measure height, weight from many number of people. Okay. So descriptive statistics use measures. Okay. So descriptive measures like measures of central tendency and mean, median, mode, and measures of deviation include standard deviation, range, variance, so etc. Okay. These techniques are used to summarize or describe the data set. So suppose you measure weight of 3 students, right? Example. So weight of 3 students. So 65, 63, 64. So this is our data set containing weight of 3 students. Now descriptive statistics to summarize this entire 3 data set by using example mean. Okay. So the average, mean means average, the average value of this student's weight is suppose 62 kg. Okay. So this indicates that average weight of the 3 students is 62 kg. So this is a summarized measure, right? So descriptive statistics used to summarize the large data set by a single value. The single value represent maybe average or center value, anything. So then come to inferential statistics, right? So inferential statistics. So inferential statistics is one of the important technique in statistics, right? So inferential statistics is also known as heart of the statistics, right? So inferential statistics plays a role in important in decision making about the population parameter, population measures. Okay. So this circle indicates the population. That means it contains large group of data or individuals, right? You take sample from this population by using sampling techniques. So there are two types, probability and non-probability. So anyway, so you take sample from the population. So the sample means what? It is a subset of population. Okay. You take measures from the sample. Okay, like mean, median, mode, etc. And then testing the sample measures. Okay. Then testing the sample measures and make conclusion about population. So this technique is called inferential statistics. So inferential statistics have two categories. So one is hypothesis testing and another one is estimation theory, right? So now we discuss about hypothesis testing. So hypothesis, what is meant by hypothesis? So hypothesis is a tentative statement about the population parameter or sample statistics. What is meant by tentative statement? So tentative statement means it is a false statement, false assumption about the result. So the result is from population parameter or sample statistics. Population parameter means measures taken from the population, right? So this is the population. It contains 100 people. The average weight of 100 people is 60 kg. So it is denoted by mean because it is the average measure. Okay. So the population measure is known as parameter and the sample measure is known as statistic. So then sample contains 30 individuals and the average weight of 30 individuals is 59 kg. So it is noted as X bar because it is a sample statistics. So population measure is known as parameter. Then sample measure is known as statistics. So hypothesis means you made a false statement about the population parameter or sample statistics is based on our research questions. Okay. Then hypotheses have many types, but mostly use two types. So one is null hypothesis and another one is alternative hypothesis. So what is null hypothesis? So null hypothesis means null. Null means empty. So that it indicates no difference or no relations or no association, just equal it means. Okay. So comparison, association, so you make no difference, significance, it's based on our research question. Okay. So this is the hypothesis that we needed to test. Okay. So it is denoted as H0. Okay. Then alternative hypothesis. So alternative hypothesis means just opposite to null hypothesis. That means it state equal. Alternative hypothesis means not equal or maybe greater than or less than. Okay. For example, so drug A and drug B, we have two drugs. So the effect of drug A and drug B is equal. That means null hypothesis. Then alternative hypothesis is just opposite to that. So drug A may be not equal to effect of drug B, or drug A less than drug B effect, or drug A greater than drug B effect. So it is called alternative hypothesis. So just opposite to the null hypothesis. Okay. So it is denoted as H1 or HA. A means alternative. Critical region and significance level. Critical region and significance level plays a major role in decision making about hypothesis. Okay. So first of all, what is critical region? So critical region is a cutoff score, right? Otherwise, a cutoff score is a set of values of the test statistics that allows to reject the null hypothesis, otherwise known as rejection region. So critical value, it is a score based on the distribution of data. This score plays a role in decision making to reject the null hypothesis. Okay. So it indicates the area of rejecting, the probability of rejecting the null hypothesis. So otherwise it is known as rejection region. So there is a rejection region values, that means the cutoff score depends on the distribution of our data set. Suppose if our data set follows normal distribution, like it may be bell shape, so it is Z distribution family. So we have many distribution families. So like example Z, T, F. So the cutoff region, that means the cutoff score is all based on the this table values. So Z table, T table, F table, chi-square table, etc. Level of significance. So level of significance means error term. Okay. So this error term used to define the size of the critical region. So and it is the probability of test statistics falling in critical region when the hypothesis is true. Right. It is also denoted as alpha. So usually alpha, that means level of significance values taken as 5% or 1%. So 5% means, so data set contain 5% of error, 95% of confidence interval. Okay. If suppose error is 1%, so confidence interval is 99%. So one tail test and two tail test. So one tail test means suppose the alternative hypothesis, so that alternative hypothesis may be increase or decrease, or like less than or greater than. Okay. So for example, see that example. So effect of drug A is equal to effect of drug B. So this shows that drug A effect equal to drug B. So one tail test means the alternative hypothesis may be greater than or less than, right? So it indicates the rejection region is placed on our alternative hypothesis less than. That means it contains one tail. Less than means the rejection region is placed on left side of the normal distribution, right? Suppose our alternative hypothesis greater than, that means the rejection region is placed on the right side of the distribution, right? So see that example. So our alternative hypothesis greater than, right? So this is our rejection. So this is the normal distribution curve. So this is our null hypothesis rejection region, that is critical regions. Okay. So these values are determined by using the significance level alpha. that I already mentioned, like maybe defaultly it will be 5% or 1%, right? This is the critical region and this is the acceptance region, right? Our null hypothesis accepted on that area if the test statistics fall in that any region, right? For right tail test, the critical region is on right side of the distribution. For left tail test, it placed on the left side of the distribution curve, right? So two tail test. So two tail test means our alternative hypothesis shows that not equal, right? See that example. So drug A equal to effect of drug A equal to drug B, then effect of drug A not equal to B. So this shows that the effect of drug B is maybe less than A or greater than A. So based on our research questions, we frame this. Okay. So defaultly, so we frame so A equal to B and not equal to. So we follow two tail. Okay. See that picture. So two tail, that means the critical region is based on two sides of the normal distribution curve. For example, so this is our curve. So this region, it means critical region, I shortly CR, that means rejection region. So it is determined by using alpha. So error term. So I assume error equal to 5%. Then this center line denotes the mean. Okay. So mean of the normal distribution. Okay. So this indicates positive deviation, right? Mean plus or minus 1 standard deviation, 2 standard deviation, etc. So this side indicates negative deviation from mean. So mean minus 1 sigma, mean minus 2 sigma, right? So the 5% it is, so this region indicates 2.5% error. So this region indicates 2.5% error. So 2.5 plus 2.5, 5% error. Okay. So for two tail test, the critical region, I mean the rejection region is placed on two side tail of the normal curve. Suppose if our test statistics falls in that area of the any two sides of the curve, so it means our null hypothesis rejected. Otherwise it fall in that region, our hypothesis, null hypothesis accepted. Yes, I mean failed to reject the null hypothesis. For one tail test, our significance level, that means 5% is placed on any one side. It may be for a right tail test, it is placed on right side of the curve. For left tail test, it is placed on the left side of the curve, right? Critical values of S statistics. For example, Z statistics means that our test data set follows, or test data set or our observed values follows normal distribution. It means if you draw your data set, it shows like a normal bell curve shape, or otherwise the mean and median and mode value of our observed data set is all equal. So this indicates the mean, median and mode. That means our data set follow normal distribution. So that we define our data set, it's come from normal distribution. Okay. So normal distribution, normality in statistics, and it is very important to analyze the data. Suppose if our data does not follow any normal, that means Z family, it may be comes under any distribution like T, K square. Okay. So it based on the data set. So for this example, I choose Z distribution, right? So our level of significance is 5%, that means 0.05, and our hypothesis is, alternative hypothesis is one side, for one side, right side, for left side and two tail. Suppose my alternative hypothesis is two side and my level of significance is 5%. So the critical region is from 1.96. Okay. So it is obtained from the normal Z normal table, right? So Z normal table. Then suppose if my error is 1%, that means 0.01, and my alternative hypothesis two tailed, my critical regions values cutoff score, that means cutoff score is 2.58. So this all values are based on the Z distribution normal table. So then, so error in hypothesis. So errors, so there are two types of possible errors in hypothesis testing. So one is type 1 error and another one is type 2 error, right? So this is our decision about the hypothesis, right? Reject null, this box indicates, so we reject the null hypothesis. This indicates failed to reject null hypothesis. That means we accept our null hypothesis. Okay. So this is the null hypothesis is true. That means the natural value of the null hypothesis is true. Okay. So this is false. So type 1 error occurred. So when you reject the null hypothesis when it is true. Okay. So it occurs type 1 error, otherwise known as false positive. Okay. So type 2 error occurs when you fail to reject null hypothesis when our null hypothesis is false. It means type 2 error or false negative. So type 1 error is denoted as alpha, okay, and type 2 error is denoted as beta. So it otherwise false negative, this is false positive. Type 2 error is also termed as power of the test. So these are all the probability value, right? So these are all the chances. Okay. So suppose you want to reduce type 1 error. Okay. So just increase the alpha term, right? That means alpha error. Defaultly we take 5%. Suppose we want to reduce the type 1 error, you just change your error term to 1%. So it reduces the probability of accepting the null hypothesis. Okay. Then p value. So p value means probability value. So probability value. So p value is a statistical measure used to validate a hypothesis against observed data. So p value also play an important role in making decision about the hypothesis. The decision means we failed to reject null hypothesis, that means accept the null hypothesis or reject the null hypothesis. For this decision making, so p values plays a crucial role, right? P value. So p value is also based on the error, that means significance level alpha, right? So usually a p value less than 0.05, that means 5% of error. So it's generally considered as statistically significant, right? That means there is some difference or relation, any association is there in that observed data set, right? So decision making based on p value. So if the p value is, that means if the probability value is less than significant value, that means alpha. Suppose if my error term is 5%, then my significance value is 0.05, right? So if my p value is less than 0.05, then I reject my null hypothesis. That means there is a alternative hypothesis is accepted. So it indicates there is any difference or any association relation somewhat based on our hypothesis, right? Our problem. Suppose if my p value is greater than alpha value, like example p value is 0.06, so it is greater than 0.05. So it indicates we failed to reject the null hypothesis. That means we accept the H0 null hypothesis. So if we accept the null hypothesis, that means what? So that means no difference, that indicates no difference or no relations, okay, whatever. Okay. So this is the decision rule based on the p value. So this is a very important steps in hypothesis testing. Okay. Statistical test play a crucial role in determining the test statistics for our observed data and also to analyze our data set. So this is the result of our analyzed data set by using the various tests. Okay. The test may be t test, chi-square, z test, one sample test, anything. Okay. So in hypothesis testing, so statistical test plays a important role. So the steps in, now we see steps in statistical test procedure. First step is set up our hypothesis. Hypothesis means what? Our assumed problem statement. So first set up your null hypothesis and alternative hypothesis. Then fix the level of significance. So that means what? Our error. Okay. So error percentage. So defaultly we fix 5% if our problem is any clinically relevant problem. So they choose error term as 1%. Okay. Confidence level as 99%. So defaultly 5% of error is taken. Then our next step is choose the appropriate test statistic. That means what are the tests used to analyze our observed data. There are many number of data. Okay. So for example, you want to compare your groups, variables. So you run t-test. Okay. So choose the appropriate test statistics based on your data set and your objective. Right. Then decision making. So decision making is based on the p-value. That means probability value. Okay. Then conclusion. Then you made conclusion about for the hypothesis. Right. So let's see an example. Suppose a teacher claims that the average weight of 50 students in a classroom is 70 kg. Right. So weight of 50 students in a classroom is 70 kg. Test whether the average weight of the students is 70 kg. So suppose a classroom consists of 50 students and a teacher claims that the average weight of the students is 70 kg. So you test whether the average weight is equal to 70 kg or anything changes, right? So based on these steps, set up the hypothesis. These steps we run the result for this sum, right? So first step is set up the hypothesis. So my hypothesis is, so the 50 students, it indicates in a class. So it indicates it's our population. So this is average. So first frame the null hypothesis. So H0. So it may be in sentence or notation. So the average weight of 50 students is 70 kg, right? Then my alternative hypothesis is it may be 70 kg or not 70 kg or less than 70 kg or greater than 70 kg. Okay. So I just use two-tail test. That means unequal. So the average weight of 50 students is not equal to 70 kg, right? In notation we frame, so the notation of population mean is mu. So mu not equal to 70 kg. Alternative hypothesis, mu1 not equal to 70 kg. So whatever null hypothesis indicates, you use not equal to or less than or greater than, right? So first step is over. We just frame our hypothesis, right? Then fix the level of significance. So I fix my error, that means level of significance is 5%. So that means 0.05. So that my probability value is what? P value is equal to 0.05 because I take 5% as my error. Okay. Then I fix my level of significance value. Then I choose my test statistics. So the variables 50 students is one group. Then it is an average. So average is measured in numerical, that means number term. So I compare one group mean. So I used, so it comes under t-test family. Then I use one sample t-test for my test statistics. So as I assume that the test statistics of my problem is 2.76. Okay. Then based on the table, so my critical region value is 5%. I use 1.96. So my test statistics modulus of t is greater than critical region, that means error region. So otherwise you also calculate your significant value, that means p value. So my p value is that's all my assumed value, right? So my p value is suppose is 0.001. So my p value is less than 0.05. This indicates we reject the null hypothesis. So this indicates there is the difference in the average weight of the students. This means the teacher's assumption is wrong, right? Then characteristics of the hypothesis. Okay. So hypothesis should be simple. That means it contains only one predictor variable and one outcome variable. So overall two variables. So you frame hypothesis using two variables. So if you frame hypothesis using more than two variables like 3, 4, so it become more complex. Then it contains 4 variables, 2 plus 2, right? So 2 variables need a set of test statistics and other 2 variable need a test statistics, okay, for testing the hypothesis. So it make very complex. So you should frame your hypothesis very simple by using only one predictor variable and one outcome variable, or otherwise one exposure and another one outcome variable. So for example, smoking is my exposure, then my outcome is lung cancer, right? So this is my outcome. So want to find any relationship between smoking and lung cancer, I mean smoking causes lung cancer. So I frame my hypothesis like there is no association or relationship between smoking and lung cancer, or there is a association between smoking and lung cancer. So you should frame your hypothesis very simple, right? Then hypothesis should be specific. So hypothesis should be specific means what? So that variable is very reliable to your research questions, right? You should specify that important variable for your research questions. It may be your objective, right? And hypothesis should stated in advance. That means you should frame your hypothesis during your proposal writing, right? In your proposal you will stated your hypothesis. So why? Because it hints to your results, okay? So finding the important variable. So you need to fix your hypothesis in advance, right? Hope you understand in that video. Thank you for watching my video.